Good morning, my dear students. I hope everyone is fine. Today we will continue our lesson about atoms and we will focus on the atomic number and mass number. So first of all, let's recall the structure of the atom or the atomic model. We said that the atom consists of three subatomic particles: protons, neutrons, and electrons. And the protons and neutrons are found in the nucleus, and electrons are in the electronic cloud around the nucleus. We also said that these particles actually hold charges. So actually the electron has a negative charge, the proton has a positive charge, while the neutron is neutral, which means it doesn't hold any charge. So now I want to ask you a question. All the matter around us, each one of it, they are not the same, right? So they are not constituted of the same atom. For example, here we have the helium. The helium is the gas that we find in the balloons, and it makes it go up. Why? Because it is very, very light. However, here we have the iron. The iron is also an element, right? But it is very heavy and it is a solid. Both of these are made up of atoms, but do they think that they are made of the same atoms? Of course not. Each one of them is made up of different atoms. So we have these different kinds of atoms, and we already took about elements, and we said we had different and several types of elements, and they are organized here or arranged here in the periodic table. So this is how much we have atoms or elements. So as you saw, the helium is very light. It's a gas and it's very light. However, the iron is very heavy. Why do you think is that? We will get that in a moment. But before we get to that, we really need to know that, of course, the atom has a mass, because all this mass will contribute to the mass of the matter itself, right? But where does this mass comes from in the atom? In this table, they show us comparison between the mass of the proton and the neutron with the mass of the electron. So the proton, which has a positive charge, it has a large mass, which is 1,840 times as massive as an electron. And the neutron has similarly the same mass as the proton, and it is 1,840 times much more or massive than the electron. So the electron actually doesn't have any mass, or we can say about it that it is a negligible mass. Negligible means it's not important. So as you can see, most of the mass of the atom is because of the proton and the neutron. Where do we find the protons and the neutrons? We find them in the nucleus. So you can guess that the nucleus contributes mostly to the mass. So the number of protons and the neutrons inside the nucleus determine the mass of the atom. However, the electron is very negligible and doesn't contribute to the mass of the atom. Now let's see here. Let's review that we took elements and compounds, right? Here we have an element consists of atom of the same kind. Here we have a compound that consists of 2 or more kinds of atom in a fixed ratio. Can you notice that the circles that we draw to represent the atom or the molecule are different sizes? Why do they draw them in different sizes? Because we have different elements, we have different atoms, as we said before. So here we have 2 examples. This is copper and this is silver. What is the difference between these two? They are constituted of different atoms. This is the atoms of the copper and these are the atoms of the silver. Can you notice that the silver are bigger than the copper, each atom alone? Why? Look at this. If you look at these atoms, you can see that we have this atom has a lot of protons and neutrons and electrons, while this one has 2 protons, 2 electrons and 2 neutrons. Do you think that these two will have the same size? Of course not. Actually, this one is much smaller. So, the number of protons inside the nucleus actually determines the identity of the atom. So, going back to the silver and copper, because the number of neutrons differed, so the element also differed. Similarly here, look, if you count the protons, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 protons, while here we have 1, 2, 3, 4, 5, 6, 7. We have 7 protons. So these two atoms are different. This is oxygen and this is nitrogen. It made different atoms because this one has 8 protons in the nucleus, while this one has 7. Also here, the calcium actually has 20 protons, while the beryllium, as you can see, it has 4 protons. And each time we have different number of protons in the nucleus, we have a different atom, a different name for the element. Okay, so we already said that the atom is neutral, right? Which means that it has 0 charge. But we also said that it contains positive charges from the protons and negative charges of the electrons. How is it possible to keep the atom in neutral if it has positive and negative inside of it? Simply, the positive charges inside of it should be equal to the negative charges inside of it. So, in a neutral atom, when there is 0 charge, the number of the protons will be equal to the number of electrons. And this number of protons, we said that it identifies the atom, right? So, we can call also, instead of always saying number of protons equal number of electrons, we can call it a new number, which is the atomic number Z. Why do we call it atomic number? Because actually it determines the identity of the atom. When we had 8 protons, which is atomic number equal 8, it was oxygen. When we had 7 protons, it was nitrogen. This is the identity of the atom. When we had 20 protons, which is the atomic number equal 20, it was calcium, and so on. So the identity differs according to the atomic number, which is equal to the number of protons and consequently equal to the number of electrons, because the atom is a neutral. And we can symbolize the atomic number with the letter Z. Now we have another number we want to study. So as we said previously, we said that the number of protons and neutrons inside the nucleus determine the mass of the atom, right? So now we can determine the mass of the atom because we knew which one or which particles determine it. So the mass, now we can represent it with the mass number, and we can say or symbolizes it with the letter A, is equal to the number of protons plus the number of neutrons, because both of them have masses. So this is all of our lesson today. I hope you understood what is the meaning of the mass number, what is the meaning of the atomic number, and how is the atom neutral? How can it achieve this neutral phase? By having equal number of electrons and protons inside of it. I hope everything is clear, and now you can solve the worksheet.